Hi, and welcome back. In the last lesson, I asked you to make a simple calculator, but using functions. Here, we'll give the program 5 numbers, let's say, and the program would store the numbers in a list. It would show me the sum, show me the average, show me the maximum and the minimum in that list. This is what my code looks like. Let me just refresh the page. Okay. So, first of all is the print function, obviously, where it just says give me 5 numbers, and then here's the empty list where I'm going to store all my numbers, and for a range of 5, which means it's going to go from 0 to 4, it's basically going to ask the numbers and store them in the list. This right here is converting the input that the user gives me into an int, and then this int gets appended to the list that's x, the empty list, that's x right now. It does it 5 times from 0 to 4, and then it prints out the numbers which are being stored in this list right here. Then I have 4 functions. Get sum, I initialize sum to 0. For each in x, I add to the sum, and then I return the sum at the end. Do the same thing for average. Here I can just call the getSum function within the getAverage function. So instead of doing the sum all over again, I can just call the function that I wrote and then return the sum divided by the length of the numbers in x. For getMax, initially I set max, the variable max, to the first value in x, and as I iterate over the values in x, I compare them with the value that's in max and each value that is being iterated over, and if each is bigger than the value currently in max, I set max to each, and then once I'm done with the list, I just return whatever max is holding. Min is the opposite of max. I set the first number to min, and then as I'm iterating over the values in x, I check if each number is less than min. If it is, then I set min to each. So min is now holding whatever the number is that is lower than the previous min, and at the end I return min. Now we have 4 print functions right here. Get sum, we already know what that does. Get average, we already know what that does. Get max and get min. This makes the print statement very simple, as we're just calling the functions that we have already defined here. So this was a fairly simple one. My solution will be in the description, and let's move on to today's lesson. So in today's lesson, we will be looking at how to pass values to functions using parameters and arguments. Parameters are values that a function can take. We write parameters as variables inside the parentheses when defining the function. These variables can be used inside the function's block of code. For example, we looked at a function called print to 10 in the last lesson. That function could only print values from 0 till 10. If we wanted to print values from 0 to 20, we would have to write another function like it. Instead, with parameters, we can just write one function called print till, and then give the final value to the function as a parameter. We can simply define a variable called x as our parameter, and whatever value x has assigned, that's how far the numbers will be printed. This is much simpler than writing a new function for every amount of values that we want printed. We can even have multiple variables as parameters. We simply separate them by a comma inside the parentheses. Parameters prepare the function to accept values. Let's have a look at how we can pass values to the function. Values can be passed to functions as arguments. Arguments are written inside the parentheses when calling the function. So, for the print till function, if we want to print numbers till 10, we simply write 10 inside the parentheses. We can send multiple values as arguments, each separated by a comma inside the parentheses. The number of arguments that you can pass to a function must be the same as the number of parameters that the function can handle. Keep in mind, however, the order in which the values are passed will be the order in which they are assigned to the variables in the parameter. For example, for a function that has x as its first parameter, y as second, and z as third, when calling that function, the first value in the argument is assigned to the first parameter, second argument is assigned to the second parameter, and so on. There is another way to assign values to parameters. we can simply assign a value to each of the parameters using the assignment operator when calling the function. This requires knowing the name of the variables that the parameter uses, and we don't always have this info. This way of passing values doesn't require any particular order to be followed, as each parameter is assigned a value directly. Now, let's try adding parameters and arguments to our programs. So, in today's lesson, we learned about parameters and arguments. Let's try coding them in now. Let's say we have a simple function called add that has two parameters, x and y, and all it does is it returns the sum of the two numbers, right? Then we can simply call print, say add, let's say 2 and 3. So now 2 will be assigned to x, 3 will be assigned to y, and then it's just going to return the sum of the two numbers, and then once it returns that, this statement will just print it out. So let's see. That's exactly what happens. Now let's say we have a list. We used this function last time too. So my list equals, before we had a function called definition print my list, and all it did was for each in my list print each. And then let me just call this function. Will it print out the items in the list? And it does just that. But here's the problem though. If I have another function called myList, if I have another list called myList2, now this program right here should work for any list, right? I shouldn't have to make a new function just to print another list. So what we can do is give it a variable, give it a parameter x, and we'll say whatever x is, just iterate over x and just print whatever it is in here. Now we just gotta pass the variable. So now I can say my list. If I want to print the first list, it prints 1, 2, and 3, or I can give it the second list, and it will print the second list this time around. So that's where functions and functions with parameters are really helpful. You don't have to write the code multiple times for different lists if you can just change a couple of things and make the function more modular. Okay. Then let's have a look at another function. Let's say we want to call the function doubler, and all this function does is print, 2 times x. And then let's call it doubler 2. And of course it's going to print it out. Since it's not returning it, it's just going to print it out. 4, 10, and it's going to keep going. We could change this to a cube, right? Let's say cuber, and we can say x to the power 3. And if we call this, it's just going to give us, oh, there's no function cube, right? Changed it, right? So let's call this now. And now it's just going to say 1,000 because 10 raised to the power 3 is 1,000. So as you can see, functions, especially with parameters, can make programming a lot more simpler because you don't have to write the same code over and over again. So let's look at one function that we looked at last time. Let's say we have a print till x. Let me define the function first. So we did this, we talked about this in the overview. Let's say for I in range of x plus 1, simply print what I is, right? And then we call this print till. Let's remove these lists, we don't need them right now. So this just prints the number. Let's make another function called def multiple of 3. Let's give it x as well. Now notice how I've given both parameters x, and they will both be using x in their respective blocks of code, but this x is different from this x. Each function gets their own variables and parameters. You will learn more about this when we talk about variable scope, but for now just keep in mind that this x is not the same as this x. Each function gets their own variables and parameters and arguments. So if x, modulus 3 is equal to 0. That means it is a multiple. Let's return true. And so you don't need the false, because if it returns true, then this statement won't even execute. But if this statement doesn't execute, then it's definitely false, because this was definitely true then. So let's check. Print till works. Let's see, multiple of 3 works. Let's give it 10 as well. Now we need to print it, obviously, since it returns a true or false. Let's see what happens, and it says false because it is not, but I know 9 is a multiple of 3. Let's see what happens, and it's true this time around. How about we make a third function called print multiples of 3 till x. Once again, this x is not the same as this x. If we assign a value to this x, or it is being used in this block of code for this function, this x will be different. So let me show you now. So let's say we say it should be 3 till. So let's say if multiple of 3x. So we sent in this value. Actually, let me go to the for I in range of x plus 1, and if I is a multiple, then print I, otherwise don't print it. And then we can remove this to say it does print, so we can just call it let's say we want to print multiples of 3 till 30, right? Let's see what happens. So now we get all the multiples of 3 up until 30. And notice how we're calling functions within functions, and that's why functions, especially with parameters and sending in arguments, when you call the functions, it makes programming so powerful. So that's it for this coding lesson, and let's move on to the problem now. So for the problem for this lesson, we're going to use the program to print out prime numbers up until a certain number. So for example, I give it the number 100, and the program will print out all the numbers that are prime up until that number, right? So I have two functions doing this. The first function is checks if the first function is called isPrime, and you pass an argument to it. It has one parameter, and it checks whether that number that's given to its parameter is prime or not. It does so by checking if the number that's given is a multiple of any number that came before it, except for 1, because 0 and 1 are not prime numbers, and the definition of a prime number is that it should only be divisible by itself and the number 1. So that's how you check if a number is prime. And then I have another function called primesTill, which calls the first function isPrime for every number from 0 till the number given. And if the first function returns true, it prints it. If it returns false, then it doesn't print it. So see if you can figure this one out. I'll show you my solution in the next lesson, and I'll see you then.